Okay, welcome. We are going to discuss about solving partial differential equations. More specifically, we'll be doing an example on solving parabolic equation. So if you remember from what we did last time, we gave the definition of a parabolic equation, which is a heat equation. So this is the structure of the heat equation. With this given initial and boundary conditions. And then to solve this equation E, we gave the steps, and then we found out that the scheme for solving equation E is given by this formula here. And then when this factor k c squared over h squared is half, then this equation reduces to this form. And the stability of this method is assured if and only if k equals to k is less than or equals to h squared over 2 c squared. So let's do an example to see how we can solve a heat equation. So here is an example. The heat equation is given by partial u partial t equals to partial squared u partial x squared, where time is between 0 and 0.2, and this x, which shows the temperature, lies between 0 and 1. And then the boundary conditions are u0t is 0, u1t is 0, and the initial condition is given by the function ux0 equals to 4x minus 4x squared, where the x value lies between 0 and 1. So we've been told to take the time step to be 0.02 and take 5 steps along the x-axis to calculate the temperature function at 0.06, t equals to 0.06. So to solve such a problem, the first thing, remember when you are deriving the formula, we said that we need to have a grid where the vertical axis is t, the x-axis is given by x, and then along the vertical axis we have j, and then along the x-axis we have I. So they tell us that we need to use 5 steps along the x-axis, and the interval for x-axis 0 to 1. So it means that then each spacing will be given by 1 over 5, which is 1 divided by 5 gives you 0.2. So the spacing on the x-axis will be 0.2. So if you can draw the sketch, so we'll have, let me just do it here. So this is 1, this is 2, this is 3, this is 4, and then this is 5. So this along the x, and then this is the t-axis, and then they have told us that we take each step along the vertical axis, the t-axis, to be 0.02. So we have, this will be 0.02. So this is 0. And then when you add 0.02, you get 0.04. And then when you add 0.2, you get 0.02, you get 0.06. So because they want us to find the values of temperature at T equals to 0.6, then we just stop at this point here. So this is our grid. So this is 0, 0.2, 0.4, 0.6, 0.8, and then this is 1.0, the last value of x. So the question at hand requires us to find the values along this row. when t equals to 0.6. So values are these red nodes, but we cannot find the values at this line before you know the values are the nodes lower than this row. So therefore, we'll also be required to know the values at these other nodal points, this point, these points below the line t equals to 0.06. So we'll have to get these values. Now, so remember, along this is j and this one is I. So this is x naught, this is x1, this is x2, this is x3, this is x4, this is x5. And when we are deriving the formula, you remember that we say that a general value x is the same as xi, and we can as well show it by just I. And a general value t is the same as tj and can just be given by j. So this value is t naught, this one is t1, this one is t2, this one is t3. So this, like, we have j equals to 0, j equals to 1, j equals to 2, and this is j equals to 3. Similarly, this is I equals to 0, I equals to 1, I equals to 2, I equals to 3, I equals to 4, I equals to 5. So then these values on the boundary can as well be given directly from the initial from the boundary conditions given in the question. We have been told that u 0, t is 0. That means that in difference form, we can write this one as u 0, j, remember t is the same as j, equals to 0. So what does this one tell us? This one tells us that whenever the values, remember the coordinates is I, j. So this tells us that whenever the value of I is 0, and then for any value of j, the value of the function is 0. So the line I equals to 0 is this t-axis. So this t-axis is what defines the line I equals to 0. So therefore, without even doing any calculation, so we know that the values here are 0, value here will be 0, value here will be 0, value here will be also 0. And then this other boundary condition, u of 1, t equals to 0, will be given by now 1. When you see from our grid here, 1 corresponds to the value x5, which is the same as I equals to 5. So therefore, that can be written as, so 1 corresponds to I equals to 5, t is general j equals to 0. This one tells us that whenever the value of I is 5, for any given value of j, we get 0. And then when you come to this this grid, this is the line I equals to 5. So which means that the value of the function at any node along this line will be 0. So this is 0, 0, 0, 0. And in difference notation, you should remember that at this point here is a point u 5, 0, because j value is 0. So remember, this is 0, not 1. And then this is u 5, j is 1. This is u 5, 2, because j is 2. This is u 5, 3. And then this point here is u, this j value here is 0. And then I value is 0, j value is 3. This will be u 0, 2. This will be u 0, 1. This is u 0, 0. So at least we have some values. These values and these values we have from the boundary conditions. Now, these middle values will use now this other, we'll use the equation, this scheme which defines the solution for any value along the j plus 1 row for this problem, and then the initial the initial condition given by this condition here. Now remember, when they tell us u 0, x, 0 in difference notation, so u 0, x, 0 u x, 0 equals to 4x minus 4x squared. So in difference notation, we can write this one as u x is I, and then 0 equals to 4xi minus 4xi squared. So this means that whenever whenever the j value is 0 or t value is 0, then for any given value of I, we have this formula here. So then now, this how we write the scheme, or how we write the values of these nodal points. So we have to calculate the value when j equals to 0, when j equals to 1, when j equals to 2, when j equals to 3. So we'll have 4 different cases, and then remember I is running from 0 to 5. So just come and write j equals to 0. So we'll have u 0, 0, u 1, 0, u 2, 0, u 3, 0, u 4, 0, u 5, 0. This j equals to, remember the first number is I, second is j. And then second case is j equals to 1. So we'll have u 0, 1, u 1, 1, u 2, 1, u 3, 1, u 4, 1, and then u 5, 1. And then we'll have next, we have j equals to 2. So u, let's write these ones below here. So next we have the case j equals to 2. So we'll have u 0, 0, 2. u 1, 2, and then u 2, 2, u 3, 2, then u 4, 2, and then u 5, 2. And then last case is j equals to 3. So we have u 0, 3, u 1, 3, u 2, 3, u 3, 3, u 4, 3, and then u 5, 3. So that's what you write. So you write all the values now to get in the value. So from the boundary conditions given, so we can actually fill whenever we have 0, any other value, the answer will be 0, and whenever we have 5, any other value, the answer will be 0. So therefore, for this one, we put here 0, we put here 0, we put here 0, we put here 0. These are the boundary conditions. And then we put here 0, we put here 0, we put here 0, and then we come and put here 0. So those are the boundary values given from what you have filled. And then now, so remember, for this case, when j equals to 0, j equals to 0 means this line along the x-axis. We'll use this initial condition given here. Remember, u x comma 0 is given by this function. So which in different form can be written as this form, that whenever t is 0, and then for any given value of I, this is the function that defines the value of the function u. So therefore now, to fill u1 0, so means the I value is 1. So we just put in the function u x 0 equals to 4x minus 4x squared. So where there's x, we replace 0.2. And when we replace 0.2 in this function here, so we'll have 4 0.2 minus 4 0.2 squared. That will give us 4 0.2, so 4 times 0.2 minus 4 times 0.2. That gives us 0.64. So therefore, this will give us 0.64. And then when I is 2, then you replace in the same function 0.4. And when you do that one, you get 0.96. And when you replace x equals to x3, which is 0.6 in that function, you get 0.96 still. When you replace value for I equals to 4, which is 0.8, you get 0.64. So those are the values. Now, for these other values, where the j value is 1, 2, 3, etc., we have to remember the scheme that any given value u I comma j plus 1 is given by k c squared over h squared into this from equation 1 ui plus 1 comma j minus 2 ui j and then plus ui minus 1 comma j and then close brackets and then plus ui comma j. So our case in this given equation, k is given as 0.02 and then c squared. So remember we had partial u partial t equals to partial squared u partial x squared. So when you compare to the general formula, which is partial u partial x partial t equals to c squared partial u partial squared u partial t partial x squared. So this c squared is 1. So therefore just be 1 over h squared. H for this case is 0.2 then squared. So when you work out this one, 0.02 divided by 0.2 square, we get a half. And when you put a half here, so we'll have a half. So this will be a half ui plus 1 comma j. So this will be now minus uij plus a half ui minus 1 comma j plus ui minus ui comma j. So this minus ui j cancels with this positive uij. So the formula reduces to ui comma j plus 1 is given by a half into ui plus 1 comma j plus ui minus 1 comma j. In fact, this is the formula given in this formula 2 here. Special case when r equals to 1 is the formula that we need to use. So so this will be the formula that will be defining this value. So to define u11, so this word guys, so this is the stem of the formula. So you just say ui comma j plus 1 equals to u1 comma 1. So this tells you that I equals to 1 and j plus 1 equals to 1. So which means that when you solve for j, you get 0. So therefore, this u11 means I is 1, j is 0 in this formula here. So therefore, we just write it, the right-hand side will be a half into, so where there's I, put 1, so it will be 1 plus 1, that is 2. And then j is 0, plus u, 1 minus 1 is 0, comma j is 0. So that is what we get. Now, when you put in the values, we have a half into u20, we have gotten 0.96, and then u00 is 0. And when you work out this one, a half of the sum, you get 0.48. And then for this one, u21, just relate here, u I comma j plus 1, u2 comma 1. So this tells you that I is 2 and j plus 1 equals to 1. So which tells you that j is still 0. So the formula will be a half into, so put here I for 2, so 2 plus 1 is 3. So u3 comma j is 0 plus u I is 2, so 2 minus 1 is 1, comma 0. And these values we have from this first case. So we'll have a half into u30 is 0.96 plus u10 is 0.64. And when you solve this, a half of the sum here, we'll get the answer to be 0.80. Next one, u31 just means I is 3 and j1 equals to j plus 1, so which means j is still 0. So we'll have a half. When you replace I for 3, so it will be u4 comma 0 plus u, and that will be 3 minus 2, that is 2. 3 minus 1 is 2, comma 0. This will be a half into these values. We have 0.64 plus 0.96. So this will give us still 0.80. And similarly, this 4(1) means I is 4 and 1 equals to j plus 1, so which means j is 0. So replacing, we have a half, so 4 plus 1 is 5, so u5 comma 0 plus 4 minus 1 is 3, so u3 comma 0 equals to a half. So replacing in the values, we have 0 plus 0.96. This will give us 0.48. So those are the values for k, for j equals to 1. So these are the answers. Now, the other case is j equals to 2. We still use the same formula, that I comma j plus 1 equals to a half into I plus 1 comma j plus I minus 1 comma j. So this was given by the boundary condition. So 1, 2 means I is 1, and then so 2 equals to j plus 1 means j equals to 1. So throughout j here will be 1, and then values of I varies as we have here. So we'll have a half into, so I is 1, so 1 plus 1 is 2, so will be u2 comma 1 plus I is 1, so 1 minus 1 is 0, so u0 comma 1. When you replace in the values, we have a half into 0.80 plus 0. This gives us 0.40. Next one, I is 2, j is still 1. So we have a half into u, so 2 plus 1 is 3, 1 plus 2 minus 1 is 1, comma 1. So this will give us a half into 0.80 plus 0.48. So the answer will be 0.64. And similarly, this means I is 3. So when you put in, you will get u 4,1 plus u 2,1 equals to a half into 0.48 plus 0.80. So you get 0.64 still. And then lastly, I is 4. So we have 4 plus 1, that is 5. So u 5,1 plus 4 minus 1 is 3. U 3,1 equals to a half into, when you put in the value 0 plus 0.80. So this gives us 0.40. And then similarly, so these are the required answers for j equals to 2. So these are the answers. And then the last case, remember we use the same formula here. So it's a half, I here is 1. So put here 1 plus 1 is 2. So u 2, 2. Because every value here, you put 3 equals to j plus 1. J plus 1 equals to 3. So which means j equals to 3 minus 1, which is 2. So every value of j will be 2 for this case. And then plus u, so 1 minus 1 is 0, 2. So when you put in, the value will be a half into 0.64 plus 0, which will be 0.32. Next will be a half. I is 2, so 2 plus 1, 3. So u 3, 2 plus u 1, 2. That gives a half into 0.64 plus 0.40. That gives you 0.52. And then next will be a half. I is 3, so 3 plus 1, 4. So u 4, 2 plus u 4, 3 minus 1 is 2. So 2, 2 equals to a half into 0.40 plus 0.64. So you still get 0.52. And lastly, a half. I is 4, so 4 plus 1, 5. So u 5, 2 plus 4 minus 1 is 3. So u 3, 2. That gives you a half into 0 plus 0.64, which gives you 0.32. So these last values for case j equals to 3 are the required values of the temperature at t equals to 0.06. So these are the values. So these are the values at t equals to 0.06. So that is how we solve the search questions. And remember, the processes are iterative, and one step affects the solution for the other step. So it means that from the word go, you have to ensure that what you do in the first step, case j equals to 0, the answers you get are correct, because they'll help you to find the values in the case j equals to 1, and the values in the case j equals to 1 will help you to find values in j equals to 2 and etc. So the answers are related to one another. So you have to be very, very careful so that you don't mess up in any of the starting steps, because when you mess, then every answer that precedes from those wrong values will give you erroneous values. So thank you.